Hello, this is the first video for the semester exam review. We're going to try and, it is a very long review, so I'm going to break it up into a couple of videos, so let's get going. The first question is, simplify each expression. Basically, there is no equal sign, so it's not saying to solve for anything, it's just saying to simplify, so to get as far as you can with combining your terms. We're not going to use inverse operations. We're just going to distribute and combine like terms. That's my abbreviation for combine like terms. Okay, so right now I've got to distribute. I have a negative, so I'm going to distribute my negative, and I get 7b. Negative times a negative is a positive. A negative times a positive is a negative. Minus, and then I need to distribute my negative 4, and I get negative 4b, and negative 4 times 8 is negative 32. Now, I'm looking for my, so I've done my distribution, now I'm looking for my like terms, and I see that I've got 7b and 4b, as well as 3 and 32. These are alike because they do not have a variable. These are alike because they have the same variable. So 7b minus 4b is 3b. Negative 3 minus 32 is negative 35. Now I have two numbers. One has a variable, the other one does not. So I cannot combine them, so this is as far as I can go to simplify. Okay, you don't have to do number 2 because it's beyond what we've done, but I'm just going to give you the quick lowdown. We get 4a, and then plus, this is 16a squared for those of you who are advanced and want to go ahead and do this. I get 5a here, plus 5a squared here. I combine my like terms. This is an a squared, this is an a squared. Same properties. And this is a regular a and a regular a. So we're just basically doing the exact same thing. We're looking for similarities. This would be 9a plus 16a squared plus 5a squared would give me 21a squared. And that's as far as I can combine. You're not responsible for that one. These I told you to X out. We're not going to worry about those. Look how fast we're going through this already. Okay. Now we're going to solve each equation. So now this does have an equal sign, so I actually have to solve for a. Find the value of the variable. So first thing I'm going to do is distribute. And I get 15a, and then plus 3 times 8 is 24, equals. That's all I can do on that side of the equal sign. Now I'm going to distribute here, and I get 3a plus 6 plus 10a. Now I'm going to combine my like terms. I have no like terms over here, so I cannot do anything on that side. I've got 3a and 10a, so I can combine those like terms, and I get 15a plus 24, because I did nothing on that side, 13a plus 6. Now I use my inverse operations. That's my third step to solving this. And that means that when I move things on the other side of the equal sign, if I'm working on the same side of the equal sign, I'm not using my inverse operations. I'm only combining my like terms. Only when I'm moving across this equal sign do I use my inverse operations. So I'm going to move my a to this side of the equation because I have a's on both sides of the equation of the equal sign. So I need to get a's on all one side. So I'm going to move my a's over here. And I get 2a plus 24 equals. These cancel each other out, and I'm left with 6 on that side. Then, if I move that up here, 2a plus 24 equals 6. Now, I need to get rid of this 24 and move it to this side of the equal sign, because I want my variable, I want to get my a by itself. So I subtract 24. I get 2a equals negative 18. Negative 24 is larger than 6, so I get negative 18. Now I divide by 2. This is another inverse operation. Since 2 is being multiplied by a, I need to use the opposite, meaning the inverse, the opposite operation. It's being multiplied, so the opposite is dividing. So I get a equals negative 9. Next. In order to check my work, I can plug negative 9 back in for my a, and I would get negative 111 for both. Negative 111 over there, negative 111 over there, and then I would check my answer. Each time you should be able to check your answer for each type of problem. There's only a few that you can't check your answer on. Okay, so here we've got negative 9 and 12. So we multiply those together, and I get negative 108n minus negative 9 times positive 2 is 18 minus 5n equals, I'm going to distribute here because I'm distributing here. I'm using first, I'm distributing negative 35n. Negative times a negative is a positive 60. So now I need to combine my like terms. I'm done distributing, I combine my like terms. I've got this and this. These are like terms. All I do is I combine them. I'm not putting anything over on the other side of the equal sign. So I just combine them and I get negative 108 minus 5. That gives me minus 113n minus 18 equals, over here I have no like terms. Everything is combined already. So I can just bring that down. I haven't done anything to that side. Now I'm done simplifying there. So now I can start using my inverse operations. I am going to add. I like to keep my n positive because that makes it easier for me in the long run. So I'm going to, I know that 113 is bigger than 35, so I'm going to add 113n to both sides. This cancels out, and I have negative 18 on this side. 113 minus 35 is going to give me 78. And it's going to be positive because 113 is larger than 35. Plus 60. Then when I subtract 60 from this side to use my inverse operations, I end up with 78, negative 78 equals 78n. Then I need to get rid of this 78. Again, I'm going to use my inverse operations. I'm multiplying, so I have to do the opposite, which is divide by 78, and I get negative 78 over positive 78 is negative 1 equals n. And that's my answer. Okay, moving on. I have my first step is to distribute. So when I distribute my 4, 36 minus 4 times 9 is 36x equals negative 8 times positive 7 is negative 56x. Negative 8 times 12 is going to give me a positive 96. You should probably check my math because you know I do make errors, but I want you guys to have done this already on your own and use this to check. So I see that 56 is x and 36. Oh wait, first of all, so I'm done with my distribution. I look to see, do I need to combine any like terms? I have no like terms over on this side. I have no like terms on this side. So I'm good with like terms. So now I'm going to start using my inverse operations. Because now I actually have to cross that equal barrier. So I'm going to add 56x to both sides. It does not matter if I add 36x or 56x. It's just a matter of making sure that when you add them, that you do your math correctly. So this, I bring down my 36. Negative 36 plus 56 is going to give me a positive 20x. This negative 56 plus 56x is going to give me a 0. So those cross each other out. And I'm left with 96 on this side. So then I need to get rid of my 36. I subtract 96, subtract 90. Oh, I'm sorry, subtract 36. Subtract 36. This crosses out. And the reason I'm doing that is because I need to get my numbers on one side. I want to get on the other opposite side of my x. So I get 20x equals 96 minus 36 is going to give me 60. Divide by 20 because 20 is in front of my x and it's being multiplied by my x. I use the inverse operation, so I divide by 20 and I get x equals 60 divided by 20 is 3. Okay. Number 8. This is, I'm going to distribute. First step is to distribute. So negative 2 times 8x is negative 16x. Negative 2 times 6 is minus 12. Then I'm going to distribute my negative 4. And I have negative 4 times 11 is negative 44. My negative 4 times 5x is negative 20x. Draw a line like that. I have no terms that need to be combined. All of my terms are combined. I have only an x and a number without a variable here, and a number without a variable here, and a number with a variable here. So I don't have any terms that need to be combined. So now I can use my inverse operations. And of course, when I'm here at this point, I've got x's on both sides and I've got whole numbers on both sides. So my goal is to get x on one side and my numbers on the other side. So I'm going to move my x's to this side. It doesn't really matter, but that's what I'm going to decide to do. So I'm going to add my 20x from the side, and I'm picking 20x because I know that I can move this and get this to 0. So I'm adding 20x to both sides. When I do that, this cancels out to 0, which is exactly what I want. Then I'm left with negative 16x plus 20x is 4x. I haven't done anything with that 12 yet, and I'm left with the 44 over here by itself. Now I have this number that I need to get rid of. This number can come on this side of the equation. I'm trying to get all my numbers on one side of the equal sign and leave my x by itself, and I'm doing it one step at a time. So I'm going to add 12, add 12. I'm adding because I'm subtracting here, so I've got to use my inverse operation, the opposite of adding 12 there. And I get 4x here equals 44, negative 44 plus 12 is going to give me negative 32. It's negative because the 44 is bigger, and I'm going up 12. Now the only thing left is to get rid of this 4, and then that'll leave me my x by itself. So when I do that, 4 is being multiplied by x. So I have to use the inverse operation and divide, because division is opposite of multiplication. That cancels out, and I get x equals negative 32 divided by 4 is negative 8. So x is 8. If I were to plug negative 8 back into this equation, it should work out that this side would be also equal to that side. All right, moving on. So now I'm supposed to sketch the graph of each line. I'm given the x-intercept and I'm given the y-intercept. We've been very familiar with the y-intercept. The y-intercept is the number on the y-axis where the line crosses the graph. So I'm going to go, the y-intercept is -3, 1, 2, 3. The x-intercept is also where the line crosses on the x-axis. So here's my x-axis, here's my y-axis. The line is going to cross at -1, so it would cross right here. So I would take my ruler, not the ruler that I love, but this ruler, and draw a line. And that's what that would look like. And that's all it's asking you to do. It's just asking you to graph it. So then we're ready to move on. Okay, now it's giving us an equation. And we notice that this equation is in standard form, which looks like this. It's not in our slope-intercept form like we like it. It's in our standard form. So we need to change it to slope-intercept form because that will tell us what our y-intercept is and what our slope is. Okay? So in order to do that, I'm going to take x minus y equals -3, and I'm going to take my x. I'm basically solving for x. I'm solving for y. I'm going to subtract x from both sides, and I get this cancels each other out. -y equals, I cannot combine these two because they are different. So I just have to put them side by side. I have to recognize that they're different and they're not going to combine. The problem here is that now I've got -y. So in order to change that -y, I'm going to have to divide by -1. So when I divide by -1, that's going to effectively change all of my signs. So I get y, positive y, because a negative over a negative is a positive, equals a negative over a negative is a positive, so I get a positive x. A negative over a negative is a positive, so I get +3. So here is my line that I'm going to graph. So I'm going to go up to my y-intercept, which is 3, 1, 2, 3. I'm going to graph that, plot that point. Then I notice the number in front of my x is my slope. In this case, there is a 1 in front of the x. So I'm going to go up 1, which is my rise, and my run is also 1. 1 over 1 is my slope. So that is my rise over my run. And I can take my ruler and graph that. And if you notice, once I've graphed it, I could also go -1 and negative, and negative and negative, and negative and negative. And it would be the same because a negative over a negative is a positive. So here I've got a +1 over a positive. This is my rise. This is my run. I could also have it be a -1 over a negative because I know that a negative over a negative equals a positive. They both are going to equal +1. Okay, moving on. Same thing here. It's in standard form. I need to get it into slope-intercept form. So I'm going to take my 4x. I'm going to come up here just so I have more room. 4x minus y equals 1. I'm going to subtract 4x from both sides. And I get -y equals, I cannot combine these, so they go side by side. This is a +1 because there's not a negative in front of it. So here's my equation up until now. However, I cannot have a -y, so I need to divide by -1, and that effectively changes my signs. A negative over a negative is a positive, so I get y equals a negative over a negative is a positive, so I get 4x A positive over a negative is a negative, so I get minus 1. It's very important that you change these into slope-intercept form. So I'm going to go negative 1 is my y-intercept. That's right here. Negative 1. My slope is 4. That means 4 is my rise. And we know that we can put a 1 under there as my run. So we're going to go up 4 because this is positive over positive. 1, 2, 3, 4, and over 1. We could also do a negative 4 over a negative 1 because a negative over a negative is a positive. I don't want to confuse you about that, but I know that sometimes on tests you don't know to go the other way, and I want you to be able to say, okay, 1, 2, 3, 4, and over 1. That's going to be right on the exact same line that we've created, because it's the same slope. Alright, next we've got, again, standard form. So I'm going to take my 6x plus y equals negative 4. I'm going to subtract 6x, subtract 6x, and I get y equals negative 6x minus 4. In this case, our y is positive, so I don't need to do anything. That's exactly what I want. I want my y to be positive, so I don't have to divide by negative 1 or divide by 1 or do anything else. I've solved my equation exactly how I've wanted to. So now I go up to negative 4. 1, 2, 3, 4. That's my y-intercept. Negative 6. Again, that's what I'm saying. I can't go down 6 because I'm off my graph. So a negative 6 over a positive 1, if this is my rise and this is my run, is going to be the same as a positive 6 over a negative 1 if this is my rise and this is my run, because both cases I'm going to end up with negative 6. Those both end up with a negative 6 as my slope. So here I can go up 1, 2, 3, 4, 5, 6, and over 1 to the left because that's going in the negative direction. And I'm going to look and double check to make sure, yes, in fact, I do have a negative slope because we know that that going away is negative. So there's my line. Moving on. Y equals 5/4 x. There is no plus or minus. I don't have a y-intercept. Actually, I do because we know 0 is a number. This is just like saying plus 0. So I know that I have, it starts at the origin. So my slope is the number in front of my x. That does not include my x. It just is the number in front of my x. So this is my rise. This is my run. We're going to go up 5, 1, 2, 3, 4, 5, and over 4, 1, 2, 3, 4. Then I can graph my line. And there you have it. Moving on. This was already in slope-intercept form, so I don't have to do anything here. I'm just going to go up to my y-intercept, which is 5. My slope is negative, and I know that it's a negative 1 because we know there's a 1 in front of the x. So I'm going to go down 1, which is negative and positive. Negative and positive. We know that we have to have one of those be a negative and one be a positive in order to keep my negative slope. If you're confused about that, then the more you practice it, the easier it's going to get. That's what my line should look like. Okay? Moving on. Oh, and here's one thing that I was going to tell you. You should be able to check your answers by picking a point on these lines and plugging them into the equation and seeing if it works. For an example, I see that this point is 1, 4, is right here. If I plug in this for my x and this for my y into this equation, would that actually work? Well, let's try it. So if y is 4 and x is 1, I've got a negative, and then here is my x plus 5. Is that actually a true statement? Does 4 equal negative 1 plus 5? Oops, sorry. Does 4 actually equal negative 1 plus 5? Yes. 4 equals negative 1 plus 5 is going to give me 4. So yes, that works out, which means that is on my line. You can pick any point on your line and plug it in. That way then you can check and make sure that you're going to have a correct answer. I'd highly recommend you do that for every problem. So here we've got y equals negative 1. So if I know y equals negative 1, I'm going to go to negative 1 and plot that. Now if I forget if my line is vertical or horizontal, what can I do? I can pick a point. If I know that y is always negative 1, x can be any number. X can be 3, because y is always going to be negative 1. Then I know, okay, well, x is 3 and y is negative 1, and I know y is negative 1 is on my y-axis, or is on my, y-axis. Then I can see that it would be a horizontal line. So that is your y equals. And remember, when your arms are stretched out, why are your arms stretched out like that? Okay. Why are your arms arrows? Okay. That's what y equals. Alright. Moving on. Sketch this graph. So now we don't have an equal sign. Before we had equal signs, so we didn't need to do any shading because y only equaled the points that are on that line. Now we have a greater than, which means we need to shade. So we've got, we're going to do this. This is the same as y. This is our m. We've got our x, and then we've got our y-intercept. So we're going to go up to our y-intercept, plot that point, which is at 4. The slope is negative, so one of those numbers has to be negative and the other one has to be positive. So I'm going to go down 4, 1, 2, 3, 4, that's negative, and then I'm going to go to the right 5, because that'll be positive. 1, 2, 3, 4, 5. Then I'm going to graph my line, but before I do, I'm going to look and see, is it a dashed line or is it a solid line? And I notice there's no equal to sign underneath that greater than. So I know it's going to be a dashed line. So I'm going to dash my line because that tells me that the solutions on that line are not going to be included. Only the ones in the shaded area. If y is greater than, that means y is getting bigger, which means I'm going to shade up above here. Now, an easy way to check your answer is to say the point 0, 0 is not included in my shaded graph. So that means that if I plugged in 0 and 0 in here, it should not be a correct statement. This should not be a correct statement. So let's try that. If I said 0 greater than negative 4 over 5 times 0 plus 4. Well, 0, I know 0 times negative 4 fifths is 0. So plus 4. Is 0 greater than 4? No, it's not. So that area should not be shaded in. That is a way for me to check my answer. Okay, number 17. We've got, again, this is in y intercept form. oh shoot, I didn't mean to write that again. This is my M, this is my B. So, I'm going to go to my y-intercept, which is a -1. Then I'm going to go, this should be a negative slope. My slope is -2, so I'm going to go down 2, 1, 2, and over +1. Or I can go +2 and -1. As long as one's negative, I keep my slope negative. I'm going to look and see, is it dashed or is it dotted? It's solid because it is an equal to sign. So when I write my line, it's going to be a solid line, which indicates that any point on that line is also considered a solution. Y is less than that. So y is getting less than, which means that I'm going to shade underneath. Again, I can check my solution. The origin is not included. Now, if I wanted to, I could pick a point inside and make sure that it does. So if I were to pick -1, -1, I could plug -1 in there. -1 greater than or less than -2 times -1 minus 1. And since I've shaded that, when I work this out, this equation should be an accurate statement to make sure that I've got it correct. So let's see, -1 less than or equal to -2 times -1 is a +2. So 2 minus 1, -1 less than or equal to +1. Is 1 bigger than -1? Yes. So that means that I've shaded it correctly. That's an easy, quick way to check. Moving on. So now we've got this in standard form. And so we got, I'm going to change that into slope-intercept form. I'm going to do that, greater than 9. I'm going to move my x, because I want it to be y less than or equal to mx plus b. So I need to get my y by itself. I don't know if it's going to be less than or equal to. I need to figure that out. So I'm going to subtract 4x from both sides, and I get, this cancels out, 3y greater than -4x plus 9. I cannot combine those because one has an x and the other one doesn't. Now I have to divide by 3, divide by 3, divide by 3, and I get y greater than -4/3 x. 9 divided by 3 is +3. So I can graph this, and I'm going to go up to +3. My slope is -4 over 3, so this is my rise, this is my run. Go down 1, 2, 3, 4 over 1, 2, 3, because this is going to be a positive. And when I graph it, I want to make sure I do a dashed line because it's not equal to, it's just greater than. It's just greater than. So since it's greater than, it's going up, which means I'm going to shade this area. Alright, that's the end for this video.